This is Mesut Şahin from Math department. So we'll talk about continuity at a point. Suppose the domain of a function f is either an interval or unions of separate intervals. A point P in the domain of f is an interior point if it belongs to some open interval contained in the domain. If it is not an interior point, it is called an endpoint. So let's look at this example. The function square root of 1 minus x squared has domain where square root of the function is non-negative. So 1 minus x squared will be non-negative. It means that x squared will be at most 1, which amounts to saying that x must lie between minus 1 and plus 1. So the domain is the closed interval minus 1 and plus 1. Interior points of this domain are all the points within this interval except at minus 1 and plus 1, which are boundary points or endpoints of the interval. So the endpoints are minus 1 and plus 1, and the rest fulfilling this open interval are interior points of the domain. For the second example, choose this 1 over x function, gx equals 1 over x, whose domain is the real numbers except the origin, because at 0, 1 over x is not defined. So the domain is the union of two separate intervals, namely the first one is minus infinity 0, and the second one is from 0 to plus infinity. Since there is no end point, the domain consists only of interior points. So let's discuss continuity at an interior point. We say f is continuous at an interior point C if there is a limit at C and that limit equals the number fc. So in this case we say f is continuous if either the limit doesn't exist or else it exists but is another number which is not equal to fc, then we say f is not continuous or f is discontinuous at c. So let's look at these examples. The first one is continuous at the origin because the function f is defined at 0, so we have the value 1 to be f0. Second, limit of f, both right limit here and left limit is the number 1. So limit of f at 0 is 1, which is also the value f0. That's why the function in item A is continuous. Whereas f is not defined at 0 here, so there is a gap here as you see. F is not defined at 0, so our function f is not continuous in item B. So in the third item, C, we observe that f0 is defined, but the value 2 is not the same with the limit of f. So limit of f at 0 is 1, but f0 is not 1, it is 2. So although limit exists and f is defined at 0, f is discontinuous at 0. So in the final item of the first row, we see that left limit is 0 and right limit is 1. And since they are not the same, there is no limit at all. So that's why the function is discontinuous there. Similarly, left limit of this function at 0 is positive infinity. Right limit at 0 is positive infinity. It looks like they are the same, so you may think that the limit is the limit exists, but the limit doesn't exist because it's infinite. So f0 is also not defined, so our function is not continuous. For both reasons, f is not defined at 0, and also there is no limit at 0. So it is discontinuous in item E also. So let's look at the item F. So you have this function sine 1 over x, which is not defined at 0 because 1 over x is not defined at 0. For this reason, it is not continuous at 0. So the function in item F is also discontinuous at 0. So we have a continuity test. We check 3 items. First, FC must be a real number. So we need to have a value attached to the point C. So we need to have FC first. Second, limit of the function must exist. So we need a limit in the second item. Third, we want these two numbers be the same. So we want limit equals the number FC. So if these 3 conditions are satisfied, then the function is continuous at C. Okay, so similar to left and right limit, we can talk about right continuity at a point and left continuity at a point, which relies on the right and left limit respectively. So if right limit exists and equals to the number fc, then we say the function is right continuous at C. And similarly, if left limit and the value of fc is the same, then we say the function f is left continuous at C. Consider the greatest integer function, meaning that this function assigns an integer that is greater than, it is the greatest integer that is smaller than the input x. Okay, so for instance, if x is any real number between 0 and 1, here, if this is x, its image y will be 0, because 0, minus 1, minus 2, they are all integers that are less than the real number x, but the greatest among them is 0. So that's why greatest integer of 0.5 is 0, for instance. Okay, so if you analyze this graph sketched using this fact, you see that it is right continuous but not left continuous at every integer, and it is continuous elsewhere. It is continuous here, for instance, at a real number between 1 and 2. It is continuous because there is this limit, this point is the limit, and suppose this is C, fc is 1, and limit of f at C is also 1, so it is continuous there. So, and at integer points, it is right continuous, because if you think about the right limit at minus 1, for instance, you see that it is minus 1, and which is the value of the function at minus 1 also. So it is right continuous, but left limit at -1 is -2. So this is -2, left limit of this function at -1, but f -1 is -1. And since they are not the same, it is not left continuous at -1. Similarly for the other integers. Okay, so we have a theorem saying that f is continuous at a point C if and only if it is both right continuous there and left continuous at the same point C, whose proof is not difficult to give. Okay, so having done continuity at a point, at an interior point, it's time to talk about continuity of a function at an endpoint. So we say f is continuous at a left endpoint C in the domain if it is right continuous there. And there is no way to talk about left continuity there. So similarly, we say f is continuous at a right endpoint C in the domain if it is left continuous there. Let's look at this example. So our function f is given by square root of 4 minus x squared, which forms half of the upper half of the circle of radius 2. Domain of this function is -2, 2, making what is inside square root non-negative. So for every x between -2 and +2, you have a non-negative value inside the square root. So -2 and +2 are endpoints, and the open interval -2 +2 are all interior points. So it is clear from the graph that at an interior point, left limit and right limit coincides with the value of the function. So there is no gap here. So our function is continuous at every interior point. And if you look at right continuity of this function at -2, you see that the right limit here is 0, and f -2 is also 0. So this equality is satisfied. So our function is right continuous at -2. Since it's not defined on the left hand side of -2, you can't talk about continuity of f on the left hand side of -2. Similarly for left continuity at 2. So you can talk about left limit at 2, which is the value 0 here. Since this limit equals f -2, the function is left continuous at 2. Thank you for your attention, and if you have further questions, you can contact me from this email address.